All right, our second section of chapter 1 is all about functions. If you recall, a function is a relation, and a relation is a set of values that have an x and y value. And in a function, each x which is also called the input value, it's the independent variable, has one and only one y value. Or output value. Which is also called the dependent variable. Now, a function can be written in words. It can be as a table. Ordered pairs. A graph. And as an equation. And in this section, you will be working with all of these different types and changing from one form to another. Relating this back to our last section, if we have the coordinates 2, 6, and 8, 12, these would be ordered pairs. In table form, they would be written like so. Either way, if we were to graph this, 2, 6 is approximately here, 8, 12 would be there, and we would have a line running from here to there. And then we could find the equation of the line like we did in the first section. So we would have to find the slope. And that would be 12 minus 6 over 8 minus 2, which is 6 over 6, or 1. Putting that into then our equation for the slope-intercept form, and picking, let's use this 2, 6 coordinate, we would say 6 equals 1 times 2 plus v. That would be 2 plus b equals 6 So then b would be equal to 4. And our equation in slope-intercept form would be y equals x plus 4. Now, if we were going to take this and write it as a function, not much changes except for this part of it. We change that to say f of x equals x plus 4. And this is read f of x or f at x, and then this part is the equation. This is merely a label. It's the name of the function. In this case, function f. This right here is the variable, and that has to be somewhere in your equation, or actually it doesn't have to be in your equation, but it's the value that gets substituted in over here. You cannot have an x here and a y here, or an a here and an r here. These have to be the same variables if there is going to be one here, but you do not have to have a variable. You could have a function, say f of x equals 2. That's a function. It just never changes. Now then, what you'll be asked to do with these functions is evaluate them. So here we have a function f of x equals x squared minus 5. And we are trying to evaluate at f of a negative 2. So a negative 2 is substituted in for x. So it becomes a negative 2 squared minus 5. Solving this then, or simplifying it, negative 2 squared is 4, and 4 minus 5 is a negative 1. And so therefore we would say f of a negative 2 is equal to a negative 1. When you substitute a negative 2 in, you get a negative 1 in the end. That means there's a coordinate negative 2, negative 1 on this graph. Now, had it asked you to find f of r, be the same thing. You would substitute r into this equation, and it would be r squared minus 5. Could also ask you to find something like f of 7. So that would be 7 squared minus 5. And 7 squared is 49. And 49 minus 5 is 44. And finally, they could ask you to find something like f of x plus 1. So in this case, x plus 1 has to be substituted in just for the x. So you would have x plus 1 squared minus 5. If it asks you to simplify this, then you would have to do that and square this whole thing. And remember, when you square something of that form, it means write it twice and then distribute it to get x squared plus 2x plus 1 minus 5. And so then finally you would get x squared plus 2x minus 4. Now another type of function you might see is one like this, where there are different parts to it. This is a piecewise function. And in a piecewise function, this is what you're using as your evaluation part. There'll probably be a comma here. This tells you which x values to use in which part. Here it says x has to be less than or equal to a negative 1. So if your value is less than or equal to a negative 1, you would use this top equation. If your value is greater than 1, then you would have to use this bottom equation. And so this first one says f of a negative 3. Well, a negative 3 would fit in this category because it's less than a negative 1. So then you would have 2 times a negative 3, which gets you a negative 6. Evaluating f of 2, 2 would fit this one because it's greater than 1. So then you would have 2 plus 3, which is 5. Finally, this one here, f of 0. Well, f of 0 is not less than a negative 1, and f of 0 is not greater than 1. So therefore, this is not part of it. You can't use this in this particular function, so there would be no answer. And you could also write that. And then lastly, f of a negative 1. That would fit this one here. So you'd have 2 times a negative 1, which is negative 2. Now, in these functions, the values you put here are called the domain. And then the answers you get are considered to be the range. In some functions, it will tell you what the domain is. In other functions, it wants you to know what the domain is. In those cases, that is called an implied domain. And an implied domain would be all values that could be used. In a function. Now, when you think about that, the first thing you should always start with when you're trying to figure out what the applied domain is would be all real numbers. In this case, you can substitute anything into this equation and get an answer if it's a real number. So therefore, the implied domain of this particular function would be all real numbers. Now, you might see the domain written as this. That is the same as that. This is just saying from a negative infinity to a positive infinity. This one here could start with all real numbers because you can put a 1, a 2, a 3, a 4, a 5 there, and you can take 3 divided by any of those. Sometimes you'll get a number less than 1, but that's okay. You can also substitute a negative value in because 3 divided by a negative 1 is still a negative 3, or a negative 2 is a negative 1.5. But you cannot put 0 into this because you can't divide by 0. So our implied domain for this particular function would be all reals except for 0. Now if you were to write this in this form, that would be from a negative infinity, comma 0, with a parenthesis, and then a union symbol, and then 0, comma infinity. A parenthesis means it does not include that value. A bracket means it does. So here we're going from 0 but not using 0 all the way to infinity. But we can't use infinity because it's a symbol. That's why you put a parenthesis on this end. And then finally this particular example, dealing with 2 times the square root of x. Well, you can put, there's a square root for 1, there's a square root for 0, there's a square root for 2, there's a square root for 3. Although those aren't whole numbers, there is a square root for 3 and 2. The square root of 4 is 2, and when you multiply that, you get 4. But you can't put a negative number under this, because the square root of a negative 1 is an imaginary number, and we're only dealing with things in the real world at this point. So therefore, we can use all reals that are greater than or equal to 0. And so then, in this case, you would put a bracket, because now we can include 0, and it goes all the way up to infinity. And for these, you have to use some common sense and understand what you can and can't multiply or divide by. Or when you have a square root or a cube root or a fourth root, know what values can go underneath. And sometimes you may have a combination of the 3 things, and so then you just have to use these as your guide. And that concludes our second section.